Hi everyone. Today we're going to review linear relationships. So we've got a pretty good grasp on rate of change and how to find it. We're just going to review where we see it in all the different representations, equations, tables, graphs, word problems, and just review how to connect it between all of them. So we're going to start with an example that gives us a word problem. It tells us that Jamie signs up for membership to Fitness Center. They charge $15 for the month and $5 per aerobics class. So the first thing that I need to pick out from those words are, what is the unit rate? What is my rate of change, or the amount that is happening every time? So if I'm looking at this, I know she pays $15 for the month. So that's just a one-time payment for the month. But then any time during that month that she goes to a class, she has to pay $5. So right here where it says $5 per aerobics class, that tells me that's my unit rate, because that's the amount she has to pay every time she goes to a class. The $15 is just a one-time fee for the month. So that can help me write an equation, because remember, when I'm writing an equation, I know my rate of change is what I'm multiplying by x. So we're using y to represent the total cost for her month, including everything. So if I say y, the total cost equals, well, she's got to pay $5 per class. We don't know how many classes she's going to go to, so remember we're using x to represent that. So $5 per class x. But that's not all she has to pay for the month. She also has to pay $15, so plus $15. Okay, so remember, once you find your rate of change, that's your amount that you're multiplying by x. If there is an extra amount, then we're just adding or maybe sometimes subtracting that at the end. Okay, so let's look at our table now. Once I have my equation, I can use that to help me fill in my table. So remember, the left side is going to be x, the right side is going to be y. So my x values are the different numbers of classes she could attend. So let's say she attends 0 classes for the month. Well, she pays $0 because she would have to pay $5 per class. Well, 0 times $5 per class is still 0. She pays no money for the classes, but she also still has to pay that $15 for the month. So if we add the $15 for the month, her total monthly cost for 0 classes is $15. If she goes to 1 class, she pays $5 for that class, plus the $15 for the month. So 1 times 5 gives me 5, plus 15 gives me 20. Remember, you can also be typing this into your calculator just as we're writing it. So for 2 classes, if she goes to 2, she pays $5 each, plus the $15 fee. So remember, you can type that in 2, parentheses, $5 per class, plus 15, so she pays $25 for the month. Same thing for 3 classes. 3 times 5 plus 15 is going to be $30 for the month. Okay, so we've got all of our different amounts. Now remember, we can graph that with our classes down here for x and our total cost over here for our y value, x and y. So I'm just going to go 0, 1, 2, 3 for the classes. And then for the cost, I'm just going to go by tens. Okay. So I know for 0 classes, she still had to pay $15. There, I see my starting amount right there in my graph. My point at 0 classes is at $15 on the y-axis. And then for 1 class, she pays $20. For 2 classes, $25. And for 3 classes, $30. So there I can see she's starting at $15, and then it goes up. Every time we add a class, it goes up by $5. So that's our graph. Okay. Now in the second example, this time we're just given an equation. We have no information to go with it. All we know is we have this equation, y equals x plus 5. So here's what I do know. Remember this extra amount that we're adding? That's our starting amount. So I know we could come up with a problem where we're starting with 5, or we're adding an extra 5. That's the extra. And it just says x. So we're not multiplying x by anything. All we're doing is adding 5 to it. So we just need to think of something that we might not know. We could say someone's age. So we could say Jack's age. Jack's age is, well, since I'm adding 5, I could say his age is 5 years older than Tina's age. So we don't know how old Jack is, but we do know that he's 5 years older than Tina. So we could say X is Tina. If we add 5 to Tina's age, we get Jack's age, which is Y. Okay? So if I put in X and Y here, X is Tina's age, Y is Jack's age. Then I can just make up some values. So let's say Tina is 5 years old. How old is Jack if Tina is 5 years old? Well, my equation tells me all I need to do is add 5 to Tina's age to get Jack's age. So 5 plus 5 gives me Jack would be 10 years old. Let's say Tina was 8 years old. I just need to add 5 to her age, so Jack's age is 13. If Tina is 10, Jack is 15. And if Tina is 15, Jack is 20. All right, so just from that one equation, we knew this was our extra amount, figured out what we were doing to it, then we could come up with a verbal description, and from there a table. So now our graph should be really easy once we have our points. So I just need to put Tina's age on the x-axis and Jack's age on the y-axis and plot my points. So we'll do 2, 4. And okay, so first thing I should notice is if Tina was 0, if Tina wasn't born yet, how old should Jack be? He should be 5 years old, right? So we should know that our line on our graph should be starting at 5 on the y-axis. So I should be starting with a point right here. If Tina is 0, then Jack is 5 years old. Okay, then I know if Tina is 5, Jack is 10, she is 8, he's 13, kind of have to estimate, 10, 15, and 15, and 20. Okay, so we see a pretty straight line here for our constant rate. Every time we add Tina's age, we add 5 years for Jack's age. Okay, and the last one, this time we're just given a graph, and we need to create the table equation and a verbal description from there. So when I'm looking at the graph, I need to be thinking about a couple of things. Is there anything we notice just by looking at it right off the bat? Well, I notice that we're comparing time in hours to temperature in degrees, and it's describing the temperature in Boston. So I can look at all these points and figure out what the temperature was after so many amounts of hours. I also noticed that my very first point on the graph is 0.25. So that means at 0 hours, the temperature started at 25 degrees. So I could use that to put in my table. I know my x-axis is hours, and I know my y-axis is temperature. I'm just going to put degrees Fahrenheit. So I already know from the graph at 0 degrees, it was 0 hours, it was 25 degrees Fahrenheit. Let's pick a couple of other points. I know Probably the closest one would be 3. At 3 hours, it was 40 degrees. Okay, now remember, to get my equation from here, all I need to do is find my rate of change. And I really only need 2 points to do that. So I have my 2 points, now I can find my rate of change. Remember to find rate of change from 25 to 40, we added 15 degrees. And from 0 to 3 hours, we added 3 hours. Remember, to get my rate of change, I divide change in y. So 15 divided by change in x, which is 3. 15 divided by 3 gives me 5, which is my rate of change. That means the temperature increased 5 degrees per hour. So in my equation, remember, I know my rate of change is always what I'm multiplying by x. So if I start with y, the temperature, to get the temperature, we multiplied 5 degrees per hour times the number of hours, which is x. But remember, when we looked at our graph, where did it start? It started at 25. Remember that starting amount, that's our extra amount that we're adding. So we have 5 degrees per hour plus the 25 degrees that we started with. We need to add that. Okay, so now we just need to describe that in words. We already know we're talking about temperature, so I just need to say something like the temperature in Boston started at 25 degrees and rose 5 degrees per hour. Okay, and then we have all 4 representations. So you should be able to go any direction between these 4 representations, whether you're given the equation, the table, the graph, or the words. You should be able to pick out the rate of change and go from there to help you create the rest of them.